I'll give that a couple of seconds while there you go. Now I can go back to the slides. That's great. Thank you, Ian, for introducing the session. My name's Ayesha. I'm actually one of Ian's PhD students. I'm halfway through my PhD that's looking into using technologies such as VR and AR, virtual reality and augmented reality, and data science such as machine learning and heuristic models in order to essentially develop technology for medical and clinical education. I'm also just starting out as a visiting lecturer also at the university, so to help improve my teaching skills. I've been at BCU since my undergraduate years, and I started off with computer games technology as a Bachelor of Science. I did that for 3 years. I focused a lot on the virtual reality and medical side of serious games, and then in my final year I started to look more into my research area, which was medicine, but it was more focused in terms of what I wanted to do for my PhD. And then at the beginning of my PhD I thought, how can I use AI to support VR and AR in the medical field, and that's where I am today in terms of looking at learners and predicting their behavior. So I'm here to talk to you today about data science, and what is data science. So it's essentially being able to acquire data and store data and compute this data in terms of GPU usage and for acquiring the data through medical devices simulators. It's quite cheap compared to other processes. So the question that we have for data science is, can we use algorithms and data in order to understand phenomena and behaviors such as prediction of user behaviors, prediction of weather forecasting, monetary forecasting, and basically anything you'd want to predict, and using trends and patterns. And how can we use this data then to build or augment models, and such as building the detectors and making diagnosis based on what we've seen in the data and the algorithms and the models. So the key question in data science, as you can see on the slides, is how do we explain and predict the world? So much like all forms, a lot of other forms of science and engineering, data science does derive from physics. It uses a lot of physics and maths and a lot of formulas in order to create such powerful predictive models. Such examples includes Newton's law, the theory of relativity, and one that I'm currently using, I used was some mathematical formulas such as Euler's distance for dissimilarity. So there's always a lot of maths involved when it comes to data analysis. How do we make predictions where we don't? Okay, backtracking on that a second. The basis of predicting is defined as a simulation. So you're using a data to simulate an event in order to create a prediction. But how do we make predictions when we don't have good models? This is essentially where it's defined from user behavior, biology, the brain, whether a product will be a success and what to invest in. This is part of what I'm doing for my PhD in terms of whether a product will be a success based on the user's behavior. For this, we need to use sampling statistics, so getting enough participants involved and using statistics like t-testing, normal distribution, normalizing our data, because normalizing data, for example, is when you have a ton of you have an activity, for example, in a simulation, and you have about 80 people using that simulation, but they all have different times, and one can take 20 seconds up to 20 minutes. So we need to normalize that data so it's a lot easier for us to mold and mess around with that data in order to get a good prediction. And another way, a way of doing that in Python especially, is you can do 1 plus the log of that amount, and that's how you can normalize that data. Um, we also we need enough representative data and the right questions for good models. This means that, say you have a database and it's missing a lot of data, that may not be useful for us to use it, because it doesn't give us a lot to play with, but also it doesn't give us a big enough picture to see exactly what's going on, and that can also lead towards bias and overfitting, which we'll talk about later in this presentation. So, but one important thing is that we do want to combine our models and data. For example, for my work especially, I have combined the Euler's dissimilarity matrix with with a clustering model called K nearest neighbors, to essentially find out which groups of people are most similar to each other, and how I can use my AI then to target all the different individual groups. And it's also combining different data in terms of all the different levels in the simulation that I have. The outline of topics for this presentation today is: what is data science, considerations around big data, what does analytics involve, a quick disclaimer and recap, then we will finish off with a checkpoint exercises, and this will include a practice notebook, which I think you all have access to, as Ian said. So before I go on to the next slide, can anyone please can anyone write in the chat what they think of, what words they think of when I say data science? So what words spring to mind? I just go back into the chat and see. So if you just write in the chat any word that springs to mind at all. Yeah, I can see a lot of all along the right lines: data handling, data manipulation, collection of data, prediction, interpretation. Well, it's, that's that is a lot of what's on the that is what a lot of people consider as being, because if we look at the word bank, if I can change, I think I can see statistics, data analysis, machine learning is a big part of it. AI, and the different types of programming languages that you can use for data science, optimizing your data, making sure it's the most efficient. Pandas, which is a library in Python, which we'll be discussing later in this session today. Simulations, communication, big data. Yeah, I'm just looking at what everybody else is writing. Yeah, collection and analysis of data and predictable gathering data, get meaningful insights that can. Brilliant. All you guys seem to have a good understanding of the definition of data science, which is what we like to see. So and again, data science is interdisciplinary. You don't have to just be a mathematician or a physician or a computer scientist. It can even go into business and law and sociology, because everything is data. You can have qualitative and quantitative data that you can all use as for good data science analysis. When you do during this course, it'll be initially focused on the technical and data manipulation aspects of data science, which we define as data and analytics. This is also known as data engineering, but data science is much broader and includes domain expertise, communicating the results to users via storytelling or data visualization, such as graphs and heuristic clustering, and also leading up to defining legal implications and policy making. And we'll get to the broader social context later, such as data ethics, which I think you're doing later in this during this week. I was looking at making sure that everything is transparent, making sure data protection laws are adhered to, privacy, fairness, and taking accountability for handling the data. We'll give examples of this throughout the course and as used in different domains. So our focus here is managing the data to create models at a specific scale. This could be a complicated or different scales could be complex, heterogeneous, large, high dimensionality, or velocity. We'll touch on many related techniques and issues such as machine learning, which I'm sure a lot of you are eager to get started on, distributed computing, algorithms, and parallel computation. But our focus here today is looking at the foundations of machine learning and cloud platforms. You should continue to study this and data analytics in depth afterwards. So, there are different types of data. We have raw data, which is essentially when you gather data. So, for example, when I did my user participation testing a few months ago, I stored all of my user interaction data into a CSV file for every user. So it's the same CSV file for every user, but each row was for a specific user, and that had their time, their queue time, their reaction time, how many mistakes they made. Yeah, like each individual thing, whether it was false or true, everything they did. That is my raw data. It's completely unstructured, but it's my observation sampled from the real world, or it could be qualitative data such as feedback, system use. So your usability scale responses, so your usability feedback, or anything you hear from word of mouth through interviews with participants. These are all your observations, and it's raw and unstructured. So what we first need to do with our data is, let me just check which environment is used in Python. Python uses Panda libraries as well as Matplotlib, as well as a range of different libraries, making Python one of the most powerful programming languages to actually use. For machine learning, it's one of the easiest to get your head around too. For this hackathon, we're going to be using Google Colab in order to load Python into, but I will show you how to do that once we finish the slides, because we've got that lab where I can show you. If you haven't been shown yet, I can show it to you today. But going back to the structured and integrated data, this is where you need to map your data into patterns. So like normalizing your data, you're giving each column a limit, and sort of just neatening it up so it's easier to work with and read, and also to allow for the machine to interpret the data in a way that's least bias. Extracted features is measurable characteristics. So this could be, say, reaction time. This could be looking at different trends. This is where you've focused on which piece of data you think would be the most important for your data analysis. And then you've got a descriptive inferential model, and this is describing the population as a whole based on the data that you've been given. And this description may be biased, again, if there's data missing or if the wrong piece of data have been acquired. But our goal in terms of data analysis using these models is to extract features that help us make predictions for the general population. So when we're looking at big data, which is data science, data analysis, we have to look at structure, cleaning, and linking. So databases often assume a closed world. So in your data, I'm just making sure that there's no questions. What is the difference between data science and data analysis? Data analysis is a part of data science. So data science, if we go back to this, data science is a big galaxy, big, this a discipline of its of its own. It's got a lot of different components, and data science and data analysis is one part of that, which we can use to carry out machine learning. We can use to carry out predictive modeling, and then our data analysis can then be used to visualize the data in data visualization. So it's part and parcel of data analysis, but we're actually a timely part of this thing. What role does AI play in this? I will get to that at the end, because I would talk. Please, can you type your project? I'm not had to post my project tool at the moment, for as I'm writing a paper, but I can talk you through what I'm what I'm I can actually talk you through my model and some of the clustering, if you like, towards the end after we looked at the lab. But it was timely that you asked about data science and data analysis, because database often assumes a closed world where essentially the database thinks it knows everything because of all the data that it's comprised of, that there is no other data but this. So in terms of like a company's employees information, like their salaries, any product they sold, how much projects have they sold, how long have they worked for, and data science is an open world where essentially we say that we can't see the whole population, because physically as human we can't actually see the population. We can't get for my PhD, for example, I can't get the feedback from every single clinical student across the world. So we've got different, we are given samples or some incomplete observations, so data might be missing in the database that the database doesn't realize is missing. And then from this data that's in the database, we use data science to predict the future or categorize the entire population. And a way of doing this is through analysis, which so it's essentially a part of and this analysis can use clustering. It can and it can use algorithms, and you'll be looking more about algorithms and clustering and regression and how and what kinds of analysis there are in on Wednesday. But how we sample affects our model. So say if we have too small of a sample, oh, just to let you know, my door might knock in a few minutes because I'm expecting a delivery, so bear with me if that happens. But essentially, when we create a model, we have to make sure that we have um, enough of that data. So for pattern of life algorithm, for example, we don't need that much but for a test and train algorithm, and we want to predict user behavior, we might need more than between 45 to 100, for example. We need to have enough some but so my train of thought is, say if we have 100 in a group, so for my PhD, for example, we have 100 students. I need a minimum of 45 just to make sure that it's and I think there is I will put into this chat later a calculator to help work out population size. Well, you can use Y-test training, which I can show you actually today, from what I've been doing for my PhD, if that helps. And there's also some in the lab, which I'm going to show you today as well. Yeah, I've gone through that. But yeah, linked data is essentially another part of one form of the algorithm where you find or where you've got each individual is a node, for example, such as this person here with a dog, and they've connected to all different other nodes, and you can map out their patterns in and based on their interactions. So you know that this Facebook friend, for example, is their connection on Facebook that's connected to the individual. You can see what they like on Facebook. You can see what they, because of their Spotify account might be linked to their Facebook. You can see what they're listening to. Yeah, again, their friend. You can see what they watch based on what they might share on their Facebook about what they're watching, and also about their cooking based on, like, say, what they post in their images or text about what they're up to. That's just one small that's a tree. So it's using this is using trees and nodes, like Dijkstra algorithm essentially. So it's again going back to concrete maths related algorithms such as Dijkstra's algorithm A star, algorithm Postman's. It's essentially using old decision maths but in computer form, and again giving it into different subclasses and then clusters based on those classes. So in terms of film and likes, just make sure. Yeah, you'll be looking at linear regression, multiple regression, supervised, unsupervised later in the week on Wednesday, I believe. And another form of data analysis is what you'd expect for a weather forecast, a forecast for the future based on current events elsewhere in the world. So currently, in this heat wave, they were able to predict this heat wave that the UK is currently going through based on conditions that were in Europe and in Africa at the moment, and then seeing that warm air being blown over through the different countries to get to the UK, but they were able to use that, predict that using AI already, using data analysis. Before we, please can we say that AI is a subfield of data science? Well, yeah, it is a component. AI and machine learning is a key component or subfield of data science. So yes, that's you could definitely say that. So this is when I said about structuring your data, this is structured data looking at somebody's longitude and latitude position in the world based on their IP addresses. And this would be raw structured data. So it's taking on the raw data, but neatening it up in a table, making it easier for the machine to understand what's going on. What makes big data? It's not gigabit data, big data. So there's no overall definition, but from our perspective, big data is data that's too hard for us to understand directly without going in and analyzing it and breaking it down. It doesn't fit a single uniform memory space, such as typical variables in Python, which means we can really think about what our input and outputs are and our communication with the data. It also might need more than brute force concrete rigid algorithms in order to analyze it, to be a bit more flexible with the with what algorithms we put into place. We need to tailor an algorithm in order to fit with the data, and it may also need sometimes multiple computers in order to work together in parallel to process this data and analyze it. And it's quite high dimensional and may require high velocity, so it's always going to be changing rapidly. But what does data analytics actually involve? This data analysis involves, first of all, pattern detection. So seeing if there's any trends in user behavior, showing me the sales, looking at different clusters of groups. So for example, for mine, I was looking at is there any pattern in terms of the different groups from the 120 participants that I had for my research. And also descriptive statistics as well. And one other aspect of data analytics is that it involves a given observation or hypothesis. So your hypothesis could be that using this app, the users will do this, or users who haven't had experience in such and such a topic will perform worse than users who have had experience, etc. And from this, we can do a statistical test to measure the significance of our data, and that's the significance. If the significance is less than 0.05, we can then accept the hypothesis to be true. So what does big analytics involve? So again, data acquisition, being able to access the data, being able to untangle the data and make sure it's in the correct form that we want, being able to represent and integrate our data. This is where the Python lab comes in. Clean our data in order to make sure that there's no anomalies, no missing data, because if there is missing data, we'll have to ignore that participant, that row completely in order to get a neat structured data so that we don't get any errors. Like I said, hypothesizing, iterating through the data to help build knowledge, and obviously making sure we handle data ethically. So there's a myth theory say that with data science we'll learn everything bottom up using fancy machine learning and data science and machine learning. Basically, we turn the crank and out pops insights. It's not as instantaneous as that. With data science, we typically have to rely on human expertise in order to impose the models over the data and be able to analyze the data as the computer works things out. Deep learning can do feature selection, but why throw away what we know? So data analytics has to include both the data and human insight and the computer algorithms in order to generate the knowledge. So the data science application process can be broken down into these next steps. What question are you wanting answering? What is the right scope of the project? What data do you need to use? What techniques are you going to try? And how will you evaluate your results? And after you evaluate your results, what maintenance will be required? So as a as a recap, data science is a massive umbrella of fields. One part of it is data analysis, which will include algorithms, AI, and machine learning. This is where I'm going to speak about how my PhD, where I have, where I'm using AR and VR as the platform, and I let the users use the simulation in okay, with mobile VR, for example. I created a mobile VR application, gave the application to users from different clinical fields and asked them to use it. And their experience with the topic varied from each person and throughout the year. So they may not have had, so that say one medical student may have had more experience in the topic of the simulation compared to a paramedic or a nurse. So I took all, and they all have different levels of technical expertise as well as coming from different ages. So all of those come into account for when I looked at the data, and from there I first used so what question am I answering? What I wanted to see is how are the users using the simulation? Is there any differences between the disciplines? What is the right scope of the project? So for this, I first used the similarity matrix and Euler's distance to see the similarity between all the different participants who used my simulation. I then took it one step further by then visualizing my data for data visualization using dendrograms, which is a process I used in Python to generate it. I didn't do it myself. Python did it all for me in seconds. And then from that, I was able that dendrogram was able to show me visually all the different clusters of students. So ones who were bad, ones who were good, and then so you got a good and bad group. And then in those two groups were also two clusters in itself. So ones who were fast but bad and slow but bad. And then in the good, you got the fast but good and slow but good. And I was able to then analyze the patterns from that. What is the user matrix? This was the user matrix in data science. Well, one is to look at the difference at the similarities between pieces of data, and to be able to cluster and also see patterns and be able to group piece of data together in order to make accurate predictions. Because after that, I then fed back the results of the dendrogram and use that to help create a rule in order to predict user behavior of the next participants based on what the first batch did, and that I then to evaluate. So that was my technique. My technique was it was creating the algorithm based on rules based on the pattern that I saw. So using K nearest neighbor algorithm, it was called. So first of all, I used the similarity matrix to see what to to see which users are most similar to each other in order to group them into different clusters, where you had a bad group and a good group, and then those two groups were then split into two groups each, where based on their speed and their how many mistakes they made. And then the techniques that I then used was K nearest neighbor algorithm to develop a develop a rule to predict user success or failure. I then evaluated my results using cumulative accuracy profiling, which is I can show you in when we look at the lab now, which is a computerized way of testing, training, and predicting your user behavior, and looking at that's data training, as well as using something called a confusion matrix, which is looking at seeing comparing whether a user was predicted to be bad and whether they're actually bad or good, and seeing whether they actually were true positive or true negative, meaning whether they were actually predicted, if they were predicted bad, that they were actually bad, that's a true negative, and if they were actually predicted to be good and they were good, then that's a true positive. But in some scenarios, you'd find that some users might be predicted to be good, but they might be actually be bad, and that's called a false positive. And essentially, the vice versa, that is a false negative. So those are the ways that I evaluate it, and the maintenance of it is currently what I'm working on by feeding it back into my simulation in order to get to evaluate more results at a wider scale. Again, data is high dimensional and could be hard to understand, and we use computers to help us understand it by extracting and selecting features, as well as adding semantic structure to the data. And there are many applications, as you have probably gathered, to data science, from discovery to clustering to classification to recommendation, sometimes statistical, sometimes algorithmic, and sometimes the data we have to rely on extracting the data ourselves. So if we go to my what I've done so far, excuse me, I will just close that. Have you guys been given access to this notebook for Python yet? The Python lab? If someone writes in the chat, have you guys been given? Yeah, okay, that's great. So you should all be able to have access this into in Google Colab. But if you haven't, it's pretty straightforward. Okay, so if you go to Google Colab, Google Research, and you should have something like this if you've logged into Google Colab and yeah, okay. So if you upload and then choose file, and the file that you want to upload is basics of python.ipynb, and then we open that, and then it will open into Colab, but I've got it open here too. So this is a lab that you guys can do with this, what we've got the time for time to do. There is this lab here for you guys to have a go at, but one thing with this is that you have to play all the different pieces in order. So like say when they say play hello world, that should show up. I think this is servers down. There you go, it prints hello world. So essentially the first half of this notebook is looking at the different examples of what you can do in Python. It goes more complicated when you look at pandas. So this is a way of again, pandas is what you use in machine learning and data analysis, and it's using the data frames. So it's using a data frame called Hubble data, and then you want to view specific columns in the way we did with the dictionary. So you have to, it'll show you how you did that in the previous thing, and then Just looking at the chat. Ideally, for this hackathon, well, you can, but ideally, if you wanted to share your work with, say, us tutors, it would be better to use Colab, just so that we can see what you're doing, or if you're struggling with it. But yeah, you can use Anaconda if you like. That's not a problem. And yes, so this is just showing you a different technique of what else you can use with Panda. And again, this is looking at recession this is essentially using our data in a database that we have regarding the distance to calculate to and sort of predict the recession velocity, and it'll show you how to normalize your data, and then it will give you an example of using everything you've done here in order to complete this exercise, which I believe you should do after this session finishes. But if you have any questions, please feel free to message in the chat. I'm here all week.